detection and 3D visualization from brain MRI scans. According to a research survey conducted by Central Brain Tumor Registry of the United States, the prevalence rate for all primary brain and central nervous system tumors was estimated to be 209 per 100,000 in 2004. This is year 2010, and the numbers are still increasing by every passing moment. It is very difficult to conduct a research in underdeveloped countries. However, it is easy to speculate that if a country like United States has this staggering rate of the disease, underdeveloped countries such as Ghana, Kenya, Afghanistan, and similar would be facing the worst. This disease comes from the spectrum of general diseases, but it is fatal if it spreads.
MRI brain is an advanced imaging modality which requires a number of sequences for the proper interpretation of the normal brain tissues and their differentiation from the pathological tissues. We also perform a number of contrast-enhanced as well as unenhanced images for tissue differentiation. And these scans usually require a number of time depending upon the kind of pathology we suspect. A normal MRI brain interpretation requires approximately 30 to 45 minutes. However, it can take longer than that as well in case we are suspecting some pathologies.
The problem involves a legion of intricacies. It is very difficult to diagnose a tumor in its juvenile states because of the overlapping hard tissue of the brain. These tissues tend to appear like a tumor, misleading a radiologist. Consider a scenario in which we add a system in the above equation, a system that is based on the entire standard practices of medical image processing in order to provide a second opinion to the radiologist. The problem has been lingering in the field of medical science for years. There are different computer-aided solutions that use the technique of digital image processing, providing three-dimensional view of an image, but Brain Inspector is the first solution which lets the radiologist to embark a paradigm where they can have an opinion of the solution itself. The system's opinion is based on clear classification, segmentation, and three-dimensional visualization of the brain. The technique to implement the solution is innovative in all dimensions. These techniques are approved in the international conferences such as 9th Visas International Conference on Artificial Intelligence, Knowledge Engineering and Databases, and the University of Cambridge, UK. This conference verifies the classification techniques that are accurate up to 99.2%. If the system is implemented on a large scale in the third world countries, it is going to affect the masses. It would eliminate most of the problems that hinder the process of diagnosing the tumor at an early stage, so that it could be removed in order to save millions of lives. If the system works in collaborative environment all over the world, we would be able to develop a semantic knowledge base based on diverse variety of brain tumor cases. This would not only help to manage the cases, but also provide assistance to radiologists who are new to the field.
The main purpose of this project is provide a decision support system to the surgeons who are involved in diagnosis and cure of brain tumors.
Brain Inspector is the software which is provided to us for the interpretation of MRI brain, and I think it's a good software for the analysis of brain MRIs by the new trainees which enter into the department and are new to the modality of magnetic resonance imaging of the brain. As it helps, this software helps in the detection of tumor and its exact size and localization. So it's a good software for the new residents.
These are 168 brain MRI scans of a patient having tumor in his brain. You can see here from these MR images, mostly does not contain tumors, but few of these have tumor in them. Now run the application. Here, first of all, we select the dataset path. Now we classify these images into normal and abnormal category. The results will be saved in two different folders, having normal and abnormal images. Classification of MRI scan is successfully completed. Now we check its result. Here you can see two different folders. In abnormal folder, 23 images are saved. These images contain tumors. Folder, all those images are saved which does not contain tumors. These are 145 in number. Now we segment those images to detect skull, brain and tumor boundaries. Segmentation successful. Now we check the results. Here, 3 different folders are formed. In head boundary folder, all skull boundaries are saved after segmentation. While in brain boundary folder, all the brain boundaries are saved. In tumor boundary folder, the tumor boundaries are saved. That's the tumor part in the image. We save these boundaries to check the accuracy of segmentation. Further, these boundaries are used for 3D modeling of skull, brain and tumor. It gives a face model of patient such that you can even recognize a person using this model. User can zoom it to get a closer look at subject, can rotate it at any angle along any axis to get a better view. We can use it to correctly locate and see the size of tumor and even rotate the image in various directions. It is user-friendly and one can easily use it. This allows the radiologist to view almost real-time digital map of a patient's brain. Brain Inspector also allows the radiologist to virtual slice the brain into sections. The developed software is fast, does not require any pre-processing beyond standard MRI analysis, and is flexible enough to be incorporated into existing complex medical visualization systems.